Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome back. We are going to be looking at quadratic functions. Specifically today in this video, it will be focusing on vertex form. Now, first of all, the quadratic vocabulary word, what does that mean? It means if you look at the equation, it'll be of degree 2. Now, degree 2, what's that mean? Basically, your highest exponent is 2. If you don't have an exponent of 2, you do not have a quadratic function. So quadratic functions come in many different formats. They do not always have to have all three components, meaning a quadratic component, a linear component, and a constant component, but they can. We're just going to go ahead and start investigating what exactly does this mean. So if you were to graph them, their graph makes a special shape, and it's called a parabola. Okay. Sometimes you might hear me talk about a happy face or a frowny face. With a happy face, it's opening up. And with a frowny face, that's opening down. And we will talk about what causes that to occur and things like that, but I did want to talk about the difference between up and down. So let's first of all think about shapes. For example, a square. Okay? If your side length is 0, then your area would also be 0. But if your side length was 1, we can see here we have 1 square. If your side lengths are 2, a 2 by 2, right? Your side length is 2, now we're at 4. And a side length of 3. Now we're at 9. Spacing these out a little bit. And I'm going to go ahead and just kind of draw on top of this. If we went 4 by 4, now the whole thing would have 16. So we started off here. And even though the side length went up 1 each time, this is very consistent, up 1. We went up 1, then we went up 3, then we went up 5, and then we went up 7. And that pattern does continue with squaring numbers, and so it's that pattern itself that helps us give the parabola shape, and it's why the slope increases more and more and more each time we go to a higher number, is because as the side length changes, the area grows a lot more than the side length, because as you can see here, from a 3 by 3 to a 4 by 4, we had to add to the length and the width, and that's why it added those 7 squares. So I'm going to look at that in a picture now, and we're basically looking at the parabola for y equals x squared. I'm mostly going to use quadrants 1 and 2 because we know area is always positive, right? And squared, it's an area, right? Kind of an easy way to remember it. Okay, side length of 0, we had 0. Side length of 1, we had 1 square. The side length of 2, we were at 4. 3, we were at 9, right? So, and I'm not going to go up any higher than that because the graph would go, I don't want to go up to 16. Now, negative 1 times negative 1 is also positive 1. Negative 1 times negative 2, or sorry, negative 2 times negative 2, and negative 3 times negative 3. And that's how we're getting this parabola. So we can see that the slope is getting steeper every time we go over 1. And this is our basic shape. We have what's known as the vertex. In this case, our vertex is a minimum or low spot. The vertex is at 0, 0. The domain, if you watched videos that I have before, we've talked about the walls. And since it's continuing to go to the left and it's continuing to go to the right, There are no walls, so our domain is everything. So from negative infinity to positive infinity. Our range, that's the floor and the ceiling. The floor always comes first. And we have a floor or a bottom of 0, and we actually use that point. So I'll use a bracket like we talked about in previous videos, and it continues up forever. So that would be the infinity. And in addition to that, we have a fancy little vertical line here. Since it's a vertical line, any vertical line crosses the x-axis. This one happens to touch at 0. X equals 0 is known as our axis of symmetry. And that's going to play a key part because if we know the axis of symmetry, we know a lot about the graph. We can utilize a table of values and just make sure that we pick a number on the axis of symmetry as our center value for our chart. And we can actually gain the shape pretty quickly no matter what format it's given to us. Today, though, we are going to be focusing on what's known as that vertex form. So this video is going to specifically focus on when the equations are written in this format. Again, there'll be a squared here because our highest exponent is 2. And that's going to have that HK shifts. So if you watch the transformation videos, you would already know what the HK shifts are. If not, the rest of this video doesn't help you out. I suggest you go back and go and look at that video. But what we're going to find out is that the vertex is going to be given to us because it's a vertex form. And that's going to be our H value and our K value. If A is greater than 0, it will open up. If A is less than 0, it will open down. And that's because, remember in that transformation video, we talked about how if you have a negative out front, it reflects it over the x-axis. If the absolute value of A is greater than 1, it'll be a stretch, meaning it's going to grow up taller faster. So instead of being a parabola like this, it would be a parabola like that. Because think about it, whenever you take something, times it by, multiply it by 4, that number gets bigger and it grows faster. So the slope is steeper, which looks like it's bringing it together faster. If, however, your absolute value of A is less than 1, that's going to be a compression. If you have a bunch of money and you multiply it by 1/2, you have less money, right? So your parabola that would have been like this now is getting pressed down and it's growing a lot slower. And so it looks wider because the slope is less. So again, keep that in mind. Also, a key point right now is that our axis of symmetry is at x equals h. So, very key point to remember there. So let's take on this example here. We're going to have f of x equals 2 x plus 3 minus 6. So looking back to our transformation video, order of operations, we do parentheses first. Inside, that would be a left 3. The A value out front is 2, so stretch by 2. And then the minus 6 is down 6. And because it's something squared, it makes a parabola, and that's our parent function. So this graph is going to be a parabola because it's like its parent, which is a parabola. Now, if you do not remember watching that video, or you skipped it, or it's just lost from your brain right now, I'm going to rewrite this function. Now it looks like in the format that I have written above, we have x minus, just like we had x minus. So our h value is -3, and our k value is -6. So our vertex is HK. or left 3, down 6. So the transformation of functions, as well as comparing this directly to the format, is going to give that to us. If you are a Missouri student, this equation is on the left-hand column of your EOC formula sheet, so you can find it there. It's always going to be there for all of your exams given to you by the state, and if you're one of my students, I always provide that to my Algebra 2 students as well. So there we see the -3, -6 is the vertex, and that is going to be the absolute most important part of this graph. So one way we can graph this is we can look at those. Okay, so we're going to go ahead and utilize this vertex to graph, and we're going to go ahead and talk about our stretch factor. Some of you will not be comfortable doing it this way, and that is perfectly okay. So the vertex is left 3, down 6. And because of that, we'll come back up, we also talked earlier about the axis of symmetry. Remember the axis of symmetry, it's kind of a fold line, right? Is that x equals our h value, which in this case was -3. So this right here is going to be our fold line. So that has to be the center of our graph. If you remember before, when I drew the squares, it went up 1, up 3, up 5, up 7. But we're stretching everything by 2. So instead of up 1, 3, 5, and 7, we're going to go 2, 6, 10, and 14. So I just multiplied those original steps by 2. So over 1, up 2, over 1, up 6, over 1 up 14. That might be a bit excessive, so I'm not going to graph that. Honestly, if you get 5 ordered pairs, it makes a great parabola. Because of the reflection and the axis of symmetry, I'm going to pop that ordered pair there and pop that ordered pair there, and we have a parabola. Make sure it's a parabola and not a V. The way that this grows here is really a lot different because of the way fractions work. So if you want to, you can experiment with 1/2 versus 1/3 and what happens when you square them. Or think about it, when you square a fraction, you're multiplying it by itself, which is a number less than 1, which actually makes it smaller. So squaring a fraction smaller than 1, whose absolute value is smaller than 1, actually makes the number smaller. So it's kind of a weird phenomenon just because of the way numerators and denominators work. If you don't like this way, that's perfectly fine. Here's what you need to know. 5 points is good to make a parabola. All right, so we need 5 ordered pairs. Make sure that this middle one is your h value. Ooh, hey, come on, focus. There we go. So our h value is -3, hence the left 3. Then I'm just going to pick any 2 numbers to each side of it. I don't care what numbers you could pick. I would choose to do them symmetrically, and I would choose to do numbers that are as close to it as possible, just so that you don't get massive answers. So I'm going to go -2, -1, -4, -5. Then I'm going to grab a calculator. 2 parentheses, -1 plus 3. So I did the extra parenthesis around my substitution. I just did it where the x was. And then there was a -6. I get 2. It also helps so that I know when I go back, that's the number I change. -4. I'm doing a copy paste feature on this calculator. I just highlight it and hit enter and it copies it down. -6. At this point, if you don't start getting symmetrical answers, you might have done something wrong with your h value. But this is a good way to test to make sure that your h value is correct, is that your y's are symmetrical. And indeed, our y values did turn out to be symmetrical. So let's check that ordered pair. Left 1, up 2. Hey, that was on that graph that we did with the pattern. Left 2, down 4. Yep. Left 3, down 6. Yep, spot on with our vertex. left 4, down 4, and left 5, up 2. So if you can find the axis of symmetry and make a table of values, then you can graph pretty much any of these equations. So that's really the big deal, is really knowing that HK shift, especially the H part of that. Okay, when you're looking at your textbook, you might be given a parabola and they might be asking you, hey, give me the equation of this thing. If you're given a parabola, you have to find the equation. The vertex is your friend. So that's the first thing we're going to find, is we're going to find that vertex. The nice thing about finding a vertex is it's just finding an ordered pair. So let's see, 1, 2, 3, 1, 2, 3, 4. The vertex is 3, 4. And instead of writing this in f of x function, I'm going to write this as y equals. According to our EOC formula sheet, we have to fill in these things. If we can fill in A, H, and K, we can be done. So remember, H and K are just our vertex. So y equals A, x minus our H, plus our K. Perfect. Not a bad deal. We now actually have to solve for the A value, and some people can look at this and just know it. For those of you who cannot look at it and just know it, I'm going to pick an ordered pair off of here. I always like to utilize positive numbers, and I'm just going to go ahead and pick this one. I know 0 can be considered positive or negative, but 1, 2, 3, 4, 5, 0. And we are going to substitute that number in to help us find our A value. So y, that's 0, correct, equals A 5 minus 3 squared plus 4. Now here's where people mess up, is they think that they can just do 5 minus 3 squared and get that and add 4. But you see how this is multiplied by A? This is the same thing as saying 5 minus 3 squared times A plus 4. So just by commuting that order, it's the same exact math, but it makes our brain think of it differently. Not sure why for some people, but hey, it happens. So 5 minus 3 is 2, and 2 to the second power is 4. So 0 equals 4A plus 4. I'll make that better for others. They like reading it 4A plus 4 equals 0. Same thing. We just went ahead and used the reflexive property that time. If you guys want to know all the fun vocab words, we reflected it. Instead of having it 0 equals this, we had this equals 0. So subtract 4 from both sides. Divide by 4. And we find out A is -1. And look at that. That first jump was over 1, down 1. It's negative because this parabola is a frowny face, or opening down. And, you know, negative people or frowny people, you know, make frowns. It's one of those ways that you can remember it. Happy people are positive people, so smiley face has a positive A. Negative people, negative A. Okay? So our final answer here should be y equals -1, x minus 3 squared plus 4. Do you have to write the -1? No. In fact, your book will not always write that. It will a lot of times write negative x minus 3 squared plus 4. In the future, you might be asked to go from this format to another format. Okay? Remember, this is vertex form, and it's vertex form because it gives us the vertex. Another form, and I will talk about this form more in other videos, is called standard form. And I just want you to know how to go from vertex form to standard form. I think you already know this, but just in case, we're going to go ahead and go through it. So x minus 3 squared really means x minus 3 times x minus 3. And we're going to add 4. And I'm going to go ahead and put that 1 back in. So here we're multiplying three things. And come over here, let's just do a reminder. 2 times 3 times 5. We can either do 2 times 3, which is 6, and then times it by 5 and get 30. Or we can multiply the 2 and the 5 first and get 10, and 10 times 3 is 30. Or we can multiply the 3 and the 5 together first and then multiply it by 2. We just have to multiply all three together. So I'm going to multiply the two parentheses together, utilizing a process that you've heard of as FOIL. In case you have forgotten what FOIL is, I'm going to go ahead and do a box version of FOIL that looks a lot like your area model from from elementary school. The only thing is different from elementary, you would have had 10, base 10, and I have an x. So our first part is x minus 3 and x minus 3. And it kind of looks like a Punnett square if you think about it too. So in this first box, we would have x times x. And when you rewrite those so that you don't have to write x twice, we would write x to the second power. Here we would have a negative 3 from the top being multiplied by the x, which is negative 3x. The same thing here, negative 3 times the x above. Negative 3 times negative 3 is positive 9. Then these two little rectangle shapes are like terms. So if you owe 3 x's here and you owe 3 x's here, you owe 6 x's total. And that's why this multiplies out to x squared minus 6x plus 9. When you multiply something times itself, it always, especially with polynomials, they get longer. So we went from having 2 variables to 3 variables. There is a meme about saving the animals. If you want to look up Save the Animals math memes. A common mistake here is forgetting this minus 6x. The math meme says, don't kill the puppies. Save all the animals. Stop making this error. So if you're one of those people who like cute memes, you can look those up again. So we're going to now have negative 1, but instead of x minus 3 times x minus 3, we're going to have x squared minus 6x plus 9. And then there's that plus 4 at the end. Order of operations still says I have to do multiplying first, so I'm going to go ahead and do that. Negative x squared, positive 6x, minus 9. And then combine like terms. If you owe $9 and you have $4, then what's your balance? You said minus 5, you were correct. So this is what's known as standard form, and that's going to be what my next video is about, is how we graph from standard form. Vertex form is right here, and I love it for graphing because it's perfect for giving me the HK shifts, and I can use my patterns to graph very quickly. The other thing is vertex form is great for domain and range. I know exactly where my middle of my parabola is, and I can just go from there.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.